Yes, good morning, class. I am audible. My screen is visible to all. Okay, right. So, continuing from the previous lecture, okay, so in the previous lecture, what we talked, let me give a small glimpse for you. Then we will continue with the lecture, today lecture. So we are talking about these two types of services, right? So in our network, we segregate all the services in these two type, right? So we classified them in connectionless and connection oriented service, right? And we need different you can see that services, right? Such as reliable, somewhere with less delay, right? Or low latency, jitter, right? All these things are required in different connections. So according to that, we did the services, and we have different types of services. Like you can see over here that we have reliable service, we have unreliable service. For like if we are talking about internet, if we are talking about some other protocols such as SMTP, right? So these are the different applications which are demanding some kind of resources in a different way. Like SMTP required resources in different way, like your internet protocol IP which we are using, it demand in different way, like telnet, right? So they have their own way of communication, and accordingly they are demanding the services, right? So but whatever the services it is, it will be fall under these two category. Please remember, this is the first important thing that you have studied in the previous class, that is connectionless and connection oriented services, right? And why we are talking about this thing? Because it basically defined the need of resources for that particular services, right? Or the way it will communicate, or the way it will establish the connection, all that thing will be defined accordingly after understanding that it is connection oriented or it is connectionless services, right? Then we come to know that these two services are further having these two protocols. So one is known as TCP protocol, right? On the one side you can see, another one is known as UDP protocol, right? So TCP is your connection oriented service. Please remember this thing. TCP is your connection oriented service and UDP is your connectionless service. This is what we have studied in the previous class till then. And after that, now we are going to discuss few examples, and we are going to have a comparison between these two services, right? So that will definitely clear you out that why we are talking about this question, that which service is better, right? Either the TCP is better or UDP is better, and why if we are saying TCP is better, then why it is, and if we are saying UDP is better, then why we are saying that it is there. So solution for all this will be covered in this lecture, and you will come to know in the end of this lecture that that which service is better, right? So that will be the takeaway for today lecture. So I'm just this demography over here will show you the orientation. Please understand that how a device which is connected on the left hand side, device A, right over here, and a device B, right? So this is one end, this is another end, right? So we are talking about end to end communication. Try to understand this thing, end to end communication, right? Whereas in end to end communication, we are providing one service that is known as connection oriented service, right? Similarly, we are also providing another service which is known as connectionless service, right? But if we are talking about connection oriented service, you can see how packets are moving in a direction. You have to focus on the direction. They are moving in a same direction because we have established a path, right? This is known as a virtual path between one end to another end. So if we are considering a connection oriented service, then what will happen first? First of all, the device will establish a connection. Please note it down, right? It will establish a connection between the two ends, right? And which demands some time. Obviously, when we are trying to connect, or we are trying to make some connection between one end to another end, what it needs some demand, because we are not immediately transmitting our packets. Packets will be transmitted only after when we have a virtual connection. You can see this is a virtual connection which is established between these two devices, right? Until the communication, this connection will be there, valid for their transfer of packet, right? So this is connection oriented, because that orientation is there between these two devices, right? And what they are doing, they are first of all, they are establishing a connection which demands some time, and in that manner we can say it is small, it is little slower, right? Because we are not transmitting packet immediately. What we are doing, first we are establishing a connection, then we are sending our packet. And you can see these streams of data, this is a stream of data which will pass through to that same path from one end to another end. This is the important point that you have to understand. All the bytes will, that stream of bytes will move into the same path, right? They are not allowed to opt for different direction or different path or the shortest path. Once the connection is established, the resource is allocated. That resource will be reserved for that communication, and that resource will be used for that connections for transferring of stream of data, right? So once that communication is over, right? So I have already told you that this is a kind of some kind of handshaking, right? So there will be a kind of handshaking such as three-way handshaking. Please remember, just remember the name. But in chapter 6, we will understand what is three-way handshaking. Then we have four-way handshaking, right? So these two devices, they will give permission to each other, right? Okay, before sending, like I am listening and I want to send a packet, right? So that's why it is saying they are establishing a connection. Then they will send a data, and then there will be acknowledgement, and then there will be disconnection of data, right? So that connection will get disconnected. So this is a way of communication is connection oriented services. And the example for this thing is, please remember this thing, that is SMTP, one of the example which we are using for this connection oriented service, or file transfer protocol, FTP, right? Telnet, TCP, Telnet. These are the some example of connection oriented service, right? What it means before transmitting data, they will establish a connection between two end devices, right? Any doubt, class? Is it clear? Yes. Whereas on the other side, you can see, let me clear the screen. On the other side, you can see, yes, this is a more logical view. You can see that these are the stream of bytes. These are the stream of bytes, nothing but the data only, right? Which we are sending in the same path and in the same sequence. Sequence order could not be changed. Try to understand that point, right? So 1, 2, 3, 4. In that sequence, the order is going and it is receiving on the destination also, right? We cannot change the sequence order. If we do that, then the receiver, you can see this is the first receiver, right? Immediate receiver of the source. Then this is receiving the packet. Then this node is receiving the packet, and finally it is received by the destination. So you can see each immediate node receiver, they are accepting in the same sequence as it was sent by the source. So sequence could not be changed, right? So we need some mechanism right over here which will maintain this thing, and the sequence will remain same, and in the same sequence it will received by the destination, right? So these are few criteria that need to be maintained, right? So yes class, I request everyone to mark your attendance by writing press. What we will do, so in this we are not establishing a connection. In that manner we are saving some time, so that's why we are saying it is much faster, right? And how packets are moving? Packets are moving in any direction, right? Please remember this thing. They are not restricted to move in a same direction as we are studying in the previous case. In the previous case, you can see they are restricted to move in a same virtual path and in a same sequence. Sequence could not also be changed, right? And one after another, it will be delivered. And you can see that for that particular of time, this resources is reserved. Right now, no other device or source or destination could able to use this this resource or path for their communication. Even they are not sending. Now imagine this part: if source is not sending any packet, and if connection is established, it is not disconnected, then also this particular path is reserved by this source and destination. What it means? It means it required a dedicated path, right? So resources once reserved, it is dedicated to that source and destination. Now there will be one more challenge because of this. If we have 5 connections, then at max we can create 5 virtual path. Try to understand this thing. And in that way, if the 6th person or the more than 5 is trying to communicate, then this thing is not possible. So this might be a limitation, you can say. So we are bounded with the resources in connection oriented service. We are bounded with the resources in a sense that if we have 10 connections, so we cannot make more than 10 connection. That is the maximum limit of virtual path that could be connected between source and destination, right? Whereas this problem will not be faced in case of this connectionless service. Try to understand, because now we are not establishing any connection which make it much faster, right? Which does not require a dedicated path, which does not require that stream of bytes need to be received in a same sequence. You can see the sequence is not same. Even here the first that datagram is sent, whereas it on the receiving end, what we have received first, we have received number 3 sequence, right? So reordering will be done. That challenge will be there in the destination side. So we need to reorder them, right? So that we can have the original form of data. That will be done with the destination. So that requires some algorithm or some method again in the receiving side, right? But sender is not worried about to establish a connection. Sender is not worried about that how the streams of bytes need to be sent. The sender will immediately send the packet, and that make it much faster as compared to connection oriented service. Now why I'm talking about all this thing in detail, because it will be easy for you to understand the comparison when we'll talk about the comparison between TCP and UDP. And that is what the takeaway of today's lecture, which will talk about this thing, that which service is better, right? So this will be the today lecture takeaway, that TCP is better or UDP is better. So that's why in that sense I'm talking about, right? So what is the good part of this connectionless service? That we don't require any kind of dedicated path. So what it means, if we have 10 resources, so only 10 user can make use of that resources in case of connection oriented service. Now scalability is included in case of connectionless service. Means we are not required, or we are not bonded with the resources, as we don't require a virtual path in connectionless service. We are simply forwarding the packet, and with the best choice, this packet can able to reach to the destination by identifying the shortest path. So this one packet which identified that, okay, moving from R1 to R2 where the bandwidth is higher, let's move to this direction and reach to the destination. So in that manner, you can say one packet will reach from this path. this, let me clear the screen for you and then we'll explain you. So you can see the first packet over here. It takes the path R1, then R3, then R4, and in this manner it will reach to the destination. After that time T2, suppose this time is T1, this time is T3. So they are all reaching to the destination at different interval. Try to understand this thing, right? So and they are not even forced or restricted to reach at that sequence or in that time only. That is the beauty of this thing, right? Otherwise we need a strict method, and that's why we need to maintain that virtual connection. But here we are not maintaining any virtual connection. One is moving in this direction, you can see, then two is moving in this direction and reaching through this. So two is moving from R1, then it is going to R3, then it is going to R5, right? And then it is going to R4, and then it is reaching to the destination. You can see. Then talking about the third packet, datagram, which is this one. So you can see it is moving through R1, then it is reaching to router R2, then it is moving to router R4, and then it is reaching to the destination, right? Whereas talking about the last datagram packet, which is moving through this R1 to R5 and then R4, right? So the path will be R1 to R5, and then it is reaching to R4, and then it is finally reaching to the destination. So we giving a flexibility for the movability of the datagram, and which basically leads to better utilization of bandwidth, right? Now, in the previous case, if we are not transmitting, then also that path is fixed and which will not be available for other source and destination. So what we are doing, we are wasting the bandwidth over here in connection oriented service. If source is not sending any packet, but still it is reserved that path for their communication, right? But this thing is not happening over here. In this, there is no dedicated path available for anyone. So what is happening? We are making use of bandwidth in a proper manner, right? So that is the best part of this thing, right? This thing is much faster. Better utilization of resources is there in case of connection-less services, right? Yes, any doubt, class? Any doubt? Please ask me. Okay. So now coming to the protocol, that is TCP and UDP. As you know, TCP is a connection-oriented service and UDP is your connection-less service, right? And one side I have taken TCP, right? Another side we have UDP, where we will discuss one by one all the feature that which I have just now discussed. All that thing is written over here, right? So TCP is a connection-oriented protocol, as it is saying, and which means that there will be establish a connection before transmitting of data, which I have already told you. Same on the other hand in UDP, datagram oriented protocol, which does not require any kind of connection and maintaining a connection and terminating a connection. So this thing is not there in case of this one, right? Which is not required. So there is a better utilization of resources, right? So but that's why UDP is efficient for multicasting type of or broadcasting type of transmission, right? Much in this case you can see where talking about reliability, as there is no kind of traffic in between, because other source and destination is not getting that virtual path. You can see over here. So we can see there is no other packet from other source and destination which could make collision. So that is not possible over here, right? So that's why it is saying in the second comparison that TCP is providing some kind of reliability as a guarantee delivery of data to the destination. Obviously, if we are providing a dedicated resources between one source to another one destination, then the chances of probability of or you can say getting collision is much lesser, right? So that is needed, and in some of the application this thing is needed, right? So all in all, what I want to say is that we cannot say that UDP is better or TCP is better. This question might be just for you for confusing, right? But yes, it depends upon the application. It depends upon the what you will answer in this particular. When a question will be asked in MST or your final exam, that which service is better, then you have to answer in this way, that it depends upon the type of application, right? In application where we need a reliable communication, some kind of guarantee between source and destination, then we will go for TCP, right? So no one is better than you can say that UDP is better than TCP or TCP is better than UDP. We cannot state this thing because it depends upon the type of application, right? So the answer for this thing is type of application, and in that what is required? If we require reliable connection, then we will go for this one, right? If in that application, if we don't require reliable connection, we require faster connection, faster data transmission, right? And better utilization of bandwidth, then we will go for UDP, right? Whereas in case of real time, like we are talking about in voice communication or video conferences, such type of reliable communication is needed, in a sense that we need to send the packet one after another in the same sequence, right? Because if I am delivering a lecture to you, and if it may use that the sequence that is receiving to you in different time interval, so it will does not make any sense. The sentence will not make any sense. So what I am saying, it should be delivered in a limited time period to you over there. Otherwise you could not able to understand, right? It will be like I am saying something and the words get jumbled and you will receiving something else on the receiving end, right? So for such type of application, like one of that connection oriented service which you have at your home, like your landline, like phone, like landline connection, that is connection oriented service. Try to understand that thing. Like, so in that, first connection will get established between that person, suppose in Jalandhar, to another person that is in Chandigarh, right? And then that resources will be available to them between these two users for communication, right? So that they can have a real time voice communication between each other, right? So that's why we are saying that it depends upon the type of application, and accordingly we are making use of TCP and UDP, right? So now next, moving to the next comparison over here, you can say delivery of data to the destination cannot be guaranteed in UDP because they are moving in different direction, and even you can see this is not user and sender only, not only participating over here, other sender and resources, that is sender and destination, they are participating, right? And what may happen, that their packet get collide because we are not providing them a dedicated path, right? So this is a kind of unreliable. That's why it is said over here guarantee is not there, right? So it provides extensive error correction mechanism, right? Because it provides flow control and acknowledge of data, right? So we will study this thing in chapter 2 when there will be a flow control topic, which is data, which will be taken care by data link layer, right? Flow control, right? We will understand this thing. Whereas UDP has only basic error checking mechanism, which is only talking about the data is not tempered in that manner, right? So that zeros and ones, we get addition of that in the end, and we take ones complement, and then we have some sequence. That sequence is added along with the data, which is known as checksum. Now receiver will do the same calculation with the data and the checksum and identify that, okay, if the two things, the header plus data value which sender has calculated and send additionally known as checksum, right? Now if there is some error or due to some kind of noise, if data is changed, you can see this value and checksum value will not get matched. So only this level of error detection is there in case of datagram. Please, you can understand this point, right? So what will error detection will be done always in the receiving side. Remember, I have told you this thing. Receiver will perform error detection. Now receiver will do separate the checksum from the data and header, separately calculate the values for data and header and identify the value, and then compare it with the checksum value. If that two value is equal, so in that manner receiver will say, okay, this is a correct data and which is received, right? So only up to this level of error detection is there, whereas in this we are having flow control and extensive error checking mechanism. We will understand in this we have some stop and wait protocol, such as simplex flow control method, go back and method, right? So this method we will discuss in chapter 2 in data link layer when it will come, right? But yes, this is there, right? So sequence of data in a feature of TCP, and that means that that packet arrive in an order at the receiver. So as you can see in the diagram, they are appearing in a sequence, how they have transmitted in the same sequence. In that order only it will get received. Whereas in case of connectionless services, the sequence is different. It can follow any order. You are not restricted. We are not this connectionless service is not restricted with the sequence. They can follow any order, but what they want to reach datagram in much faster way, right? So there is no sequence of data. You can see over here in UDP there is no sequence of data which will be managed, right? So TCP is comparatively slow than UDP. This is what the first statement I have told you in the beginning of this lecture, that it is slow because it establishes a connection. First of all, it will identify the resource, whether the resource is available is or not, right? If all the resource is reserved, then sender has to wait for the availability of resources, right? So in one example, I just want to in festival, when you are trying to reach to your colleagues or to your friends or family member, what will happen? You have seen that in many cases you have get the receive that unable to connect, right? So you're trying, you are using your device, mobile device. This is a connection oriented service, and you are trying to connect with your parents, right, or your friends. So because of heavy utilization of resources, everyone is using resources is not left anymore. So if any other person is now trying to use that resource, then what will happen? You cannot able to connect to your friends, colleagues, right? So that is a problem with connection oriented service, right? That problem is not there. And why it is slow? Because they are establishing a connection, maintaining a connection, identifying a resources, right, and all that thing. If connection get lost, then again they will establish a connection before transmitting of packet, right? Then they will transmit acknowledgement. There will be flow control between that data link layer, and then they will transmit the packet, which will be followed by acknowledgement. So that's why it is saying it is slower. Whereas these things are not required in case of UDP, which is much faster, because we are not establishing any connection. We are following different path. Packets are allowed to move in any direction, and we don't even maintaining any sequence. They can able to reach in any sequence to the destination. Now it's the duty of destination to reassemble them, to form it in an original message, to make it back to the original message, right? This is the additional work which add-ons at the receiving side, right? So we can say retransmission of lost packet is possible in case of this, but there is no retransmission of lost packet in case of this one, right? Whereas you can see the header length is something around 20 to 60 bytes, whereas over here it is having fixed. That's why I'm saying it has a fixed length. Header length is fixed. Data could be vary. There will be some understand in that manner that if we have some 1 MB of data and we are dividing into small chunks, so it may happen that large packet may not require the entire that window to be get covered, right? So since it is divided into small chunks. So in the end, it may require, suppose you can see that we have 1024, and if we divide, so these are equally divided, but in the end, we are not left with much of the data. So it can have varying data, but fixed header length, right? That we will learn in UDP when it will come, don't worry. But yes, it has a varying length header and it has a fixed length header, right? Heavy weight, as you can understand, connection oriented, light in weight, right? So the services, the application or the hardware which cannot able to handle this much of resources, right? In that case, what we can use UDP. So that's why I'm always saying this thing, that none of the service is better than other one, in a sense that it depends upon the type of application that we are using, right? And in that manner, we will opt for that service. TCP does not support broadcasting, right? So in a service where broadcasting is required, then TCP cannot support. But what does UDP does? Because packet can move in any direction, so broadcasting could be possible in case of UDP, whereas in TCP, you can see they are coming through the same dedicated path. So how broadcast could be possible in this case? It is not possible. So that's why, yes, you can see that it is reliable, TCP is reliable, but there is some problem, that is broadcasting is there, right? Over here, UDP is unreliable, but it is much faster, it is much efficient, bandwidth is much better utilized, and it is in lightweight, where it is also provide broadcasting, right? So that is why we can say in this manner, right? So TCP is used for this type of services. You can see these are the protocols. This is known as hypertext transfer protocol, right? This is hypertext transfer protocol secure, right? This is FTP protocol, SMT protocol, and telnet, which I have told you earlier also, right? Whereas UDP is used in DNS, domain name service, dynamic host configuration protocol. These are the FTP protocol, like extended version of FTP, which also support UDP. Because in FTP in the later stage, we come to know that, okay, this is not feasible for low configured device, right? So in that manner, we need an additional protocol. So TFTP was designed, right? Then SNMP is there, routing information protocol, RIP is there, and voice over internet protocol is there. These are the example of UDP, and these are the example of TCP, right? So 5 to 10 marks question will be there, that compare TCP and UDP services along with the example, and give some protocol, name some protocol which we are using in TCP and we are using in UDP. So in this manner, you will cover and you will score a good marks. And if a question is there that why we are or which service is better and why, so you can say that none of that is better from each other, in a sense, because it depends upon the type of application, and in that way we are using them, right? So in where we require faster service, then we can go for UDP. Where we require reliable service, then we can go for TCP, right? In that manner, you have to explain this question. Any doubt, class? Yes, you can ask if you have any doubt. Let me call some name. Yes, Anmol. Anmol, are you there? Turn on your mic. Anmol?
Yes, sir. No doubt.
No doubt. Is it clear?
No. Yes, sir.
Okay. Yes. Anup Kumar, turn on your mic. Yes, Anup, is it clear? Connectionless service and connection oriented service.
Clear, sir.
And if the question will come to you, which one is better, then you could able to answer that also, right?
Yes, sir.